Hi guys, and welcome to the video for complex rational expressions. So in this section, we are learning to simplify rational expressions that contain fractions in the numerator or denominator. This is a necessary skill for pre-calc for simplifying trig identities, and then you'll know you're successful when you can reduce a rational expression that has a fraction in either the numerator or the denominator, and you're going to be accurate about it. So a complex fraction is the quotient of two fractions. So we're going to start off with this idea here. Complex fractions are never considered to be in simplest form, and they can always be simplified using the division of fraction rules. So remember, divisions of fractions would be flip, factor, cancel, rewrite. In situations where you just have numbers, you can skip the factor part, but you can do any canceling and reducing, and then rewrite your final answer. So how does that apply to rational expressions? First, let's take a look at an example of we're gonna solve that fraction. So what I'm going to do is the process for solving this is to first rewrite it as a division problem. So 3/4 divided by 9/10. That is what it means to be a complex fraction. And then, after I do that, here's where my F, C, R kicks in. I'm going to flip, factor, cancel, and rewrite everything that I possibly can. So I'm going to flip this first to make it the product. So I'm going to multiply of two fractions. So I have 3/4 times 10/9. And then in a rational expression, here's where I'd start factoring tops and bottoms. And then I would look to cancel stuff. In this case, I can just go ahead and multiply top by top, bottom by bottom. And I get 30 on the top over 36. So now I'm going to try to cancel some stuff and rewrite it. I know those are both divisible by 3. If I divide both by 3, I get 10/12. And if I divide those both by 2, I think I'm going to put divide by 3, divide by 3. If I divide both these by 2, I get 5/6 as my final answer. So the final answer to 3/4 over 9/10 is that it is the equivalent to the expression 5/6. So how does that apply to complex rational expressions? A complex rational expression is a quotient that has rational expressions in the dividend, divisor, or in both. So simplifying these in the exact same way that we would the complex fraction that we just did. We're going to rewrite it as the product of two. We're going to first rewrite it as the quotient of two, because we've already learned how to divide rational expressions. And then we're going to flip, factor, cancel, and rewrite. And our first example is that expression right there. X plus 5 divided by x squared minus 16 over x to the x squared minus 25 over x minus 4. So the first thing that I'm going to do is rewrite it as division of the two problems. So I'm going to put a division sign here. And then it would be x squared minus 25 over x minus 4. You might be asking yourself, or saying to yourself, do I really need to write it as division then flip it? What you could do is you could potentially write it as the product and then automatically flip the second problem. So you don't have to spend so much time rewriting stuff here, but I'm just showing every step for completeness sake. So you'd write it as times x minus 4. You're going to flip that second fraction. I don't like the fraction bar that I made, over x squared minus 25. So what I was just saying was you could jump immediately to the second step that I just wrote. If you get practiced enough and you understand that we are writing as division and because you can't really divide fractions, you write as the product of the reciprocal. If you do those two things at once, that's okay for saving space, but just remember that is the actual operation that you're doing. Now I need to remember that I have to flip, factor, cancel, rewrite. Well, I already took care of the flip. So now I'm going to factor. X plus 5 is a binomial, but it definitely cannot be factored. Same with x minus 4. But x squared minus 16 can be canceled because I know that it is the difference of two squares. Like x squared is a square and negative 16 is a square. So on the top, I'm going to have x plus 5. On the bottom, I'm going to have x minus 4 times x plus 4 times, and then we have the x minus 4 up on the top still. And then x squared minus 25 is the same as x squared minus 16, except instead of 4s, it's going to be 5s. X minus 5, x plus 5. So then we're going to cancel what we can. I'm going to use my red pen to do this. I can cancel an x minus 4 here because it is also up here. And then I can also cancel an x plus 5 and x plus 5. So that leaves me with nothing on the top. I have nothing. But when we actually have nothing, we need to remember that we don't write nothing. What we really did here is we did a 1 for the x plus 5 over 1, and a 1 and a 1 here. So the only thing left in the top is 1 times 1, so I get a 1. And on the bottom, I get x plus 4 times x minus 5, which I do not expect you to FOIL out. So there is your simplified rational expression. I'm going to center my 1 here. 1 over x plus 4 times x minus 5. Okay, we have another example, kind of the same thing, where we have two simple expressions over each other. So remember that we need to rewrite it as the division of two things, and then we're going to flip, factor, cancel, rewrite. So I'm going to have x plus 2 over 2x divided by x squared minus 4 over 4x squared. So now what I can do is rewrite that. I'm going to flip the second one to fulfill the first f. So x plus 2 over 2x. And then that's going to be times 4x squared. Excuse me. Ooh, started rewriting without thinking. 4x squared times x squared. Whoa, man, I'm getting ahead of myself. X squared minus 4. So that takes care of the flip. So now we're going to factor. X plus 2 cannot be factored. 2x cannot be factored. 4x squared really can't be factored. But this bottom one, x squared minus 4, can. So we'll rewrite the entire left rational expression because there is nothing to factor there. And then we'll rewrite the denominator because there is nothing to factor there. But on the bottom, I know that x squared and 4 are both squares, so it would be the difference of two squares. So you have x plus 2 times x minus 2. And then I'm going to take my red pen here and do the canceling of x plus 2 and x plus 2. Remember, that leaves me with 1 and 1 in their place. And then I could look at these two here, 2x and 4x squared, and I realize that I can reduce 4 and 2. This would be a 1, and this would be down to a 2. I can cancel this x, one of the x's up here with the x down here, and leaves a 1. So on the top, I have 1 times 2x. So my final answer, my final rewrite here, would be 1 times 2x on the top, or 2x. And then on the bottom, I've got 1 times 1 times 1 times x minus 2, so that leaves x minus 2. And there is nothing left to cancel, so that is our final answer, 2x over x minus 2. Okay, so now there's a curveball. We've got some addition, we have some subtraction. Simplifying this is going to take a little more effort than before. So what we are going to do first is, again, we're going to flip it, or we're going to rewrite it as a division problem. So I'm going to have 2x minus 4y over x y squared times, or divided by, not divided, times, divided by, we haven't flipped it yet, 3x minus 6y over x squared, x cubed y. Now I'm going to flip it. Okay, remember, we're going to flip it now. Then we're going to factor what we can, cancel, and rewrite. So flipping the second part, I am lazy, and I'm going to take this and duplicate that one because it's nice and easy to just duplicate it, times. We're going to have x, too big of an x, x cubed y over 3x minus 6y. All right, so let's see what we can factor out here. We can factor 2x minus 4y. Each one of those has a 2 in common, so we're going to factor that out. So we did the flip, so we're on to the factor part. We'll have a 2, and it will be x minus 2y. Note that if I distributed the 2 back to both those terms, I would get exactly what I started with, over x y squared times x cubed y divided by, and then I have 3x and negative 6y, both have a 3 in common, so we'd have x minus 2y, and I think you're kind of seeing what we can now cancel. So remember that the x and the y's have multiplication signs between them. So I now have an x minus 2y on the top and the bottom that I can cancel into 1 over 1. I have a y and a y squared, so I can cancel the y on the top and reduce it to y squared on the bottom. So that leaves a 1 there. Oh, no, not a 1 there. It leaves a 1 on the top. And then I can cancel this x, leaving a 1 there, and reduce this to x squared. So now what I am going to do is multiply everything straight across, because I have canceled everything that I can. So I am left with 2 times 1 times x squared on the top, so it would be 2x squared on the top. And on the bottom, I have 1 times y times 3, or 3y. So there's nothing else that we can reduce, and that is our reduced rational expression. Okay, here's where the curveball comes in. What happens when one of the top, or the denominator of our complex, so what happens when either this or this has addition or subtraction in it? Well, things get a little more complicated. So we're combining a couple skills here. We're combining addition, subtraction with our division, multiplication. So again, the first thing you need to do is rewrite it as a division problem. So 8 over x plus 4. And then take away 2 over x plus 7. Remember that order of operations says that the division happens first, so you can't really do anything right now with those. So just wait until we finish writing everything out. Divided by x plus 8 over x plus 4. Okay, so we have rewritten it, and then what we're going to do is we're going to flip it first. So we're going to have these two over here are going to stay the same. These are going to be the same. But now we're going to have multiplied by x plus 4 over x plus 8. And I know what you're thinking. I know immediately that you're thinking, Mr. Wirtz, let's cancel that x plus 4 with the x plus 4 on the bottom. We can't. Okay? When we have a subtraction problem like this, these are in their own little bracket, in own little world. They cannot be touched until they cannot be canceled or anything until there's nothing but multiplication left. So we'd actually have to do the subtraction first before we do any cancellation. There's no factoring to be done here, so the flipping is done and the factoring is done. But now we have to actually simplify so that we can cancel. So what we're going to do is create a common denominator. So in this situation, we are going to create a common denominator. So we're going to create a common denominator here. And to do so, the easiest strategy is to multiply by the denominator of the other. I'm going to multiply 8 over x plus 4 times x plus 7, and then the other one is going to be times x plus 4. So I'm going to multiply x plus 7 over x plus 7. And then this one here will be x plus 4 over x plus 4. I just don't have that much room. So what we're going to get on the top of the next line would be 8x plus 56. And then the bottom, when I come to these kinds of expressions where I have x plus 7 and x plus 4 like multiplied by each other, I'm just going to actually just write them as being multiplied by each other rather than trying to FOIL them out. That takes too much time because then you're going to have to go back and factor what you just FOILed. So we're not going to duplicate our efforts here. And then on the top of the other one, I get 2x with the minus sign between them plus 4. No, plus 8, excuse me. 2x plus 8. And then the bottom will be the x plus 7. Oh, well, let me... Cool. Over x plus 4. And then that's all in its own separate world times the x plus 4 over x plus 8 from before. So we have a lot going on here. The next thing that we're going to do is we are going to combine like terms. So on the top we get 8x take away 2x, so we get 6x on the top. And then 56 take away 8 is 49. No, it is 48, excuse me, 48, positive 48. So we get 6x plus 48. And then on the bottom, we have x plus 7 times x plus 4 still. I'm going to see if I can grab it. Nice. Because I am a little bit lazy. Okay, so this represents the entire bracket combined times x plus 4 over x plus 8. So I'm going to put a little note here. Now that we have a problem with with only multiplication of binomials of expressions, we'll say, we can cancel terms. So now that we actually have a problem with only multiplication, like you see 6x plus 48, that's a binomial. A binomial times a binomial on the bottom, and then times binomial over binomial. So because there's no actual addition or subtraction like here, like in the previous step, we're allowed to start canceling. So I'm going to take my red pen, and I can cancel this x plus 4 and this x plus 4, leaving 1 and 1. I also see that 6x plus 48 has a 6 in common. So I could technically rewrite this as 6 times x plus 8. And then, well, I can cancel. So I'm going to be able to cancel this with this, leaving a 1. And it's going to leave a 6 up on the top. So I'm left with a final answer, and I wanted to switch back to black. I am left with a final answer of 6 on the top, 6 times 1, over, and then I'm left on the bottom, x plus 7 times 1 times 1, so it's just x plus 7. So yeah, that was quite a tricky one. We had to combine a couple of skills here. We combined adding, subtracting, creating a common denominator, dividing, turning it into multiplication, and then our skills of factoring, canceling, and rewriting. So a lot of stuff going on in this problem. We have one more just like it. Simplify 9 over x plus 2 over 3x over 9. Okay, so in this type of problem, we have fractions in the numerator, and then in the denominator, I only have 9. In each one of these types of problems, where it's either the numerator or the denominator is just a number, you need to put it over 1. In order to be able to simplify these, we need to treat it as 9 over 1 because we're going to need fractions to pull this off. So first we're going to write it as 9 over x plus 2 over 3x divided, and I'm going to put that in a bracket because that is going to be something that I have to deal with first. And then this is going to be divided by 9 over 1. So essentially, I'm going to take these things, I'm going to copy them, and I'm just trying to accelerate how fast I get through this. It's going to be times 1 over 9. So I have flipped it. The next thing that I'm going to do is, before I factor, I need to make sure I deal with this bracket. So before factoring, deal with bracket. So what we are going to do is I need to create a common denominator between x and 3x. Well, usually our go-to thing is multiply by the denominator of the other. In this case, we don't need to. X can be made into 3x by multiplying by 3. So we're just going to multiply this times 3 over 3. When I do, I get 27 over 3x plus 2 over 3x, still in a bracket. Didn't like that bracket. Times 1 over 9, which we have not dealt with that yet. Okay, so the next thing we're going to do is add those together. We're going to get 29, 27 plus 2 is 29, over 3x, multiplied by 1 over 9. So here's where we're going to deal with the factor part. There is nothing to factor, so we're going to go right on to canceling, and then we're going to go on to rewriting. 29 times 1 on the top, we simply get 29. And on the bottom, 3x times 9 gives me 27x. And 29 and 27 have nothing in common, so that leaves me with my final answer completely rewritten as 29 over 27x. So that's it, guys. This one was a little bit of a long video. I apologize. We learned with this video what a complex fraction is and what a complex rational expression is. We learned how to simplify basic complex rational expressions, and we learned how to simplify complex rational expressions that have addition or subtraction in the denominator, and complex rational expressions that are divided by like a number or a single expression like 9 on the bottom or in the numerator. So that's it for today's video, guys. Thanks for watching, and I will see you in the next one.